Hey guys, we are talking about a new unit now. Last Friday you had a reading about electricity, or specifically magnetism. We're building off of that today. I'm going to start with a little review because these ideas are connecting back to our chemistry unit, but are primarily really important for this. So remember that atoms, so all matter, all stuff, is made up of three different subatomic particles. Protons, which are positive, neutrons, which are neutral, and electrons, which are negative. Now, protons and neutrons are really big compared to electrons, and they don't go anywhere. And electrons are able to move around, so the negative part moves around. So negative charges do the moving, protons are in the nucleus with the neutrons. So like charges, like positives, if I have two positives, those things repel or push apart, and we'll see that today. And opposite charges, like a positive and negative, they are attracted. So if I put two protons next to each other, they will push apart. And if I put a proton and electron next to each other, they'd pull together because opposites repel. Like charges repel, opposites attract. Not all materials allow electrons to move the same. Conductors such as metal or graphite allow electrons to move. Insulators such as plastics or rubber allow charges to, or do not allow charges to move. So that is taking us into something that we'll build out a little bit more next week. I just want to introduce this a little bit. Electrons, when they move, create current. Okay, so when electrons move, that creates current. Now, in order to create movement of electrons, you have to have some type of pushing force, and that's what we call voltage. And we'll talk more about that next week. So don't worry about that a ton today. I just want you to see a couple things, and you don't have to write any of this down. Current's measured in amps, so we see different household objects have different amounts of current. Voltage is measured in volts. And voltage is what allows current to move or forces current to move. So how much it's able to push is dependent upon something called resistance. So voltage, current, and resistance are really important for this electricity stuff that we'll talk about this unit. So this will connect a little bit here, because when we're talking about magnets, they are a type of electrostatic force. And that's what we mean here. Electro meaning like electric, right? So like charges repel, positives push away, opposite charges attract. Magnets are essentially objects that create electrostatic force. Okay, so magnets have two ends, northern and southern poles, so to speak. Like poles, just like charges push apart, and opposite poles attract. That's why if you ever have two magnets and you push them, put them next to each other, sometimes they snap together and sometimes they push apart. So what's happening in a magnet? So in a magnet, electrons are lining up and they point in the same direction, causing this positive and negative end. And most magnets are made out of metal, and some magnets can be permanent and hard, and some are soft and temporary. So you can create magnetic fields, or certain objects can have a permanent magnet in them. So if you look at this video here, I like this one because it shows the electrostatic forces at play here, because this individual pushes this metal ball here with very little force, right? But then as it's attracted to this next one, it causes an acceleration because of the magnetic field of the next one to the next one and so forth. So you get this increase of electrostatic force as the ball moves across the track, causing an increase in speed, right? Remember from our Newton's unit, force is mass times acceleration. So increase in force causes, or an application of force causes acceleration. So that's an example of an electrostatic force at work. So magnets have two poles, as we see here, north and south. Yeah, this is not geographic. Our Earth has north and south poles. It's actually not magnetic, though. It's geographic. So magnetic poles go from north to south, or magnetic fields go from north to south. Okay? if you notice the arrows here always point from north to south. And that's kind of what we see here. And charge always flows in a certain direction as well. So one pole, the north, is negatively charged, and one pole, S, is south. That's positively charged. So we always get a movement from negative to positive here. So if I look at this image above, what do you think the lines from north to south represent? It represents the magnetic field of that magnet, or the direction that charged particles will flow. So if you cut a magnet in half, what do you think is going to happen? Okay, so you might think that if I go here, cut it in half, I would get a northern and a southern, a positive and a negatively charged object. But actually what you end up getting is two smaller magnets with the strength of the magnet cut in half. So if I were to cut it into 4 pieces instead of 2, each of these would have 1/4 the strength of the original magnet, but I'd have 4 magnets. And similarly here, if I cut it lengthwise, I would end up with 2 magnets with half the strength of the original one. So that's kind of an interesting property here of magnets. You'd assume maybe that I wouldn't get that, but because the electrons are lined up, just because I cut it in half doesn't mean they aren't lined up anymore. It just means a smaller amount of them are lined up. So right here, question 3, redraw the magnetic field lines. So as we saw on our last slide, magnetic fields always go from north to south. So I always want to draw from north to south, from north to south. And then I just have to draw an arrow on there showing that same process. And that it's the same thing here, from north to south, from north to south. Even though they're cut, doesn't mean that it's from north to south, from north to south, doesn't mean that it's any different. So all these actually have the same magnetic field because they are all lined up together. If I separated them, then it would be smaller. And then label north and south poles as positive and negative. Well, charge always goes from negative to positive. So every S is positive, every N is negative. I'm just going to draw a couple of them in here. If you want to label all of them, go for it. North negative, south positive. That's a great way to remember it. So notice here that the negative on the Earth is actually in the South Pole. So it's kind of confusing. But the friction in our core causes a magnetic field, or electrostatic force. And actually the poles, the North Pole and the South Pole, by geography, are flipped from the magnetic north and south. And as we saw last week, the Earth's magnetic field is really important to protect us from radiation. It also causes the northern lights. Okay, so the magnetic fields have very important properties when it comes to the Earth. If you want to watch this video, you can. It's about the eventual reality that our magnetic field will flip, so the north and south poles will flip here, and what that'll do. So go ahead and watch that video. You can click on it in the PowerPoint. Now, one application of magnets is something called a solenoid. So a solenoid is a wire that is wrapped around a piece of metal, and then when you run current through it, it causes movement of the magnet. Okay, so this relates as I put charge through this one direction. Notice current's going this way. It causes this magnet to go in, and as I run current the opposite direction, it causes the magnet to go out. So your cars use these a lot. Anytime there's a push and pull, a lot of times you're getting a solenoid. So think about like your engine uses this as well. And there was a reading that we were going to do with this, but I'm just going to simplify it. Say like, okay, an application of magnets is solenoids, which are used in your car for basically every push and pull motion. So now you got homework on page 3. There's a couple of different questions here. It should be pretty simple, just labeling north and south poles. Magnets isn't going to be a super complex topic for us. Just got to know the basics. And then there's also a little bit of review of electrons, protons, and neutrons on page 4. I would recommend trying both those things. All right, guys, have a great day. Love you. Bye.